First flow proof, we have two triangles that are sharing a side within a bigger triangle. And we see that there are two pieces of given information. One, that AC is congruent to BC. And since that's a congruent statement in this flow proof, we'll go ahead and show that those two segments are congruent in our diagram. The reason here is simply given because within our given information, we were told that two segments were congruent. And so what we're going to do in these flow proofs is we're going to mark congruent information along the way, and we'll keep track of everything in the end. So I'll show these two congruent segments here. Now, also in our given information, we are told that D is the midpoint of segment AB. And let's think about what a midpoint is, okay? So the given information here does not have a congruent statement, but it does have important information. A midpoint is, remember, halfway between 2 points. Halfway between 2 points. And so if we can find point D, which is here, and read that it's the midpoint of AB, which is from top to bottom here, that means D is halfway between A and B. And so now we should know that AD is the same length as DB. And the reason here isn't given because in our given information, it didn't say that AD is congruent to DB. We knew that these two pieces were congruent because of this keyword midpoint. And so our reason is simply going to be definition of midpoint. And it's okay to abbreviate some words here, such as definition. And we'll mark that in our last diagram. Okay, and so we are actually out of given information. And at this point, we need to have some guaranteed information for us. And so what we need to realize is that these two triangles use the same side. The top triangle has a side of DC. The bottom triangle also has a side of DC. And because they both use the side of DC, we say that they share this side. And so that side is the same amount in each of these two triangles. And the reason for that, as we've seen in the past, is called the reflexive property. This is the reflexive property of congruent segments. There's also a reflexive property of congruent angles and reflexive property of equality. But for us, we're just going to call it reflexive property and kind of cover everything in one. Okay, so we've marked it there. We'll mark it in our final diagram. And so what we see is that we've shown three different pieces of information as congruent between our two triangles. In the end, if we look at our two triangles, and sometimes it's easier if we just look at one of those two triangles, we should see that we've marked all three sides in each of these triangles as congruent to the three sides in the other triangle. And that would be our theorem of side, 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 stating that triangle ACD is congruent to triangle BCD.